Does anyone know what the string theory is? It is a set of attempts to model the four known fundamental interactions: gravitation, electromagnetism, strong nuclear force, weak nuclear force together in one theory. Seems boring, right? But breaking it down, it's very interesting. The string theory proposes that the fundamental constituents of the universe are one-dimensional strings rather than point-like particles. String theory also requires 6 or 7 extra dimensions of space. It contains ways of relating large extra dimensions to small ones. The string theory takes us all before the Big Bang and before Genesis, according to Nico Kaku. According to Einstein's model, we are like insects on a soap bubble, which is explaining the Big Bang theory. But the string theory is that there's more bubbles out there. When two bubbles collide, it creates one universe. And when two bubbles separate, it's two of the same universe. String theory has gone through many name changes over the years. This list provides an at-a-glance look at some of the major names for different types of string theory. Some versions have more specific variations, which are shown as subventions. These different variants are related in complex ways and sometimes overlap. So this breakdown into subventions is based on the order in which the theories develop. Now, if you hear these names, you'll know they're talking about the string theory, which the names are bosonic string theory, superstring theory, type 1, type 2A, type 2B, the M theory, matrix theory, brain world scenarios, Randall-Sundrum models, or the F theory. Key event strings theory's history is a young science. It has had many notable achievements. What follows are some landmark events in the history of string theory. In 1968, Gabriel Benzino originally proposes the dual resonance model. 1970 string theory is created when physics interpret Benzino's model as describing a universe of vibrating strings. 1971 is incorporated, creating superstring theory. 1974, string theories are shown to require extra dimensions, and objects similar to their gravitation is found in superstring theories. 1984, the first superstring revolution began when it's shown that animals are absent in superstring theories. When the theory was originally developed in the 1970s, the filaments of the energy in the string theory were considered to be one-dimensional object strings. One-dimensional indicates that a string has only one dimension, length, as opposed to, say, a square, which has both length and height dimensions. These strings came in two forms: closed strings and open strings. An open string has ends that don't touch each other, while a closed string is a loop with no open end. It was eventually found that these early strings, called type 1 strings, could go through 5 basic types of interactions as shown in this figure. And this is what it looks like. Get this. That's what that looks like. Okay. Type 1 strings can go through 5 fundamental interactions based on different ways of joining and splitting. Another mathematical result of string theory is that the theory only makes sense in a world with more than 3 space dimensions. Our universe has 3 dimensions of space: left, right, up, down, and front, back. 2 possible explanations currently exist for the location of the extra dimensions. The extra space dimensions, generally 6 of them, are curled up to incredibly small sizes, so we never perceive them. We are stuck on a 3-dimensional brain, and extra dimensions extend off of it and are inaccessible to us. A major area of research among string theorists is on mathematical models of how these extra dimensions could be related to our own. Some of these recent results have predicted that scientists may soon be able to detect these extra dimensions, if they exist, in upcoming experiments because they may be larger than previously expected. You'd be able to move forward or backward in time just as you can in space. Say, while walking down a corridor, you'd also be able to see the similarities and the differences between the world we inhabit and other possible worlds. In the sixth dimension, you'd move along not a line but a plane of possibilities and be able to compare and contrast them. In the fifth and sixth dimensions, no matter where in space you inhabit, you'd witness every possible permutation of what can occur, past, present, and future. In the seventh and eighth and ninth dimensions, the possibility of other universes open up, ones where the very physical forces of nature change, places where gravity operates differently and the speed of light is different, just as in the fifth and sixth dimensions, where all possible permutations in the universe are evident before you. In the seventh dimensions, every possibility for these other universes operating under these new laws become clear. In the eighth dimension, we reach the plane of all the possible histories and futures for each universe, branching out into infinity. In the ninth dimension, all universal laws of physics and the condition in each universe became apparent. Finally, in the 10th dimension, we reach the point where everything becomes possible and imaginable. For string theory to work, 6 dimensions are required for it to operate in a manner that consists with nature. Since these other dimensions are on such a small scale, we'll need another way to find evidence of their existence. One way would be to peer into the past using powerful telescopes which can hunt for light from billions of years ago, when the universe was first born. One problem is that this theory is hard to test outside of advanced mathematical equations. Some experiments have been done using supercomputers, which can run simulations and make predictions. That isn't exactly enough to prove that it's true, but it's helpful and lends support. Besides astronomical observations, physics are hopeful that experiments with the Large Hadron Collider at CERN on the Francisco-Swiss border may offer evidence of extra dimensions, lending string theory greater credence.